Now let us see some physical properties of the compound. Physical properties. Okay, in short, yes, quinoline is a colorless liquid. Its boiling point is 238 degrees Celsius. Then it is sparingly soluble in water, very less soluble in the water, but easily soluble in the organic solvents like ether and alcohol. And yes, it has a characteristic smell. Like विशिष्ट प्रकारचा वास आहे. It has a characteristic smell. Okay, now let us see some chemical reaction. First, about the electrophilic substitution. Always nitrogen is numbered as 1, then this is 2, then next one 3, then 4, 5, 6, 7, 8, and then 9, and lastly this 10. Now question arises, at what position electrophile attack on the quinoline? Always quinoline undergo electrophilic substitution at position 5 or 8. These are the two possible positions where electrophile can attack, and hence quinoline undergoes electrophilic substitution at position 8 or 5. Let us see nitration reaction. Quinoline, when it reacted with mixture of concentrated HNO3 and concentrated H2SO4, that mixture is called nitrating mixture. Quinoline, when it reacted with that nitrating mixture, we get mixture of two products. This is position 8 actually. Hydrogen atom from the position 8 is replaced by NO2 group. Then second possibility, hydrogen atom from the position 5 can be replaced by NO2 group, and we get mixture of these two products. First one is the 8-nitroquinoline and second one is the 5-nitroquinoline. 8-nitroquinoline is a major product, and thus quinoline on nitration we get mixture of these two products, 5-nitro and 8-nitro, and this is an example of electrophilic substitution. Let us see one more example, sulfonation. Quinoline on reaction with fuming sulfuric acid at high temperature 220 degrees Celsius. Again here also there are two possibilities, 8 and 5. Hydrogen atom from the position 8 is replaced by sulfonic group, and it can be replaced from position 5, and we get another compound. Thus there is a mixture of these two products. First one is the quinoline 8 sulfonic acid, and second one is the quinoline 5 sulfonic acid, and thus quinoline on reaction with fuming sulfuric acid we get the mixture of these two products. One is the quinoline 8 sulfonic acid and second is the quinoline 5 sulfonic acid. Here also major product is the quinoline 8 sulfonic acid. Okay, this is example of electrophilic substitution. Okay, now let us say example of nucleophilic substitution. In quinoline, nucleophile attack at the position 2 similar to pyridine. Okay, now let us see how the nucleophile attack. Consider example of soda amide NaNH2. When quinoline is created with the soda amide at high temperature, now what happens? Yes, hydrogen atom from the position 2, that hydrogen atom is replaced by NH2 group, and we get this compound. This is nothing but the 2-aminoquinoline. Okay, thus when quinoline is created with soda amide, hydrogen atom from the position 2, that hydrogen is replaced by NH2 group, and we get the 2-aminopyridine. This is example of nucleophilic substitution. Let us see one more example of the same reaction. Reaction with C4H9Li, N-butyl lithium. When quinoline is created with N-butyl lithium, here also nucleophilic substitution occurs, and that hydrogen atom from the position 2 is replaced by N-butyl group. We get the 2-N-butyl quinoline. This is 2-N-butyl quinoline. Okay, let us see next example. Reaction with the phenyl lithium. When it is created with the phenyl lithium, again hydrogen atom from the position 2 is replaced by phenyl group, and we get corresponding 2-phenyl quinoline. And these three are the examples of nucleophilic substitution. When quinoline is created with the soda amide, we get 2-aminoquinoline. When it is created with the N-butyl lithium, we get 2-N-butyl quinoline. And finally, phenyl lithium, when it reacts with the quinoline, hydrogen atom is replaced by phenyl group, and we get the 2-phenyl quinoline. These are the examples of nucleophilic substitution. Okay, now last reaction, yes, reduction. How the quinoline undergoes reduction? Reduction means there is addition of hydrogen, or there may be removal of oxygen, but here actually addition of hydrogen takes place. Now let us see how the quinoline undergoes reduction by using different reducing agent. Okay, we will see some examples of the reduction. First, by using sodium and ethanol. This is ethanol. When the quinoline is treated with the sodium and ethanol, there is addition of two nascent hydrogen atom takes place, and that two hydrogen atoms adds to that nitrogen and carbon. Here addition of that two hydrogen atom takes place, therefore one pi bond gets disappear and we get this compound, and this is nothing but the dihydroquinoline, 1,2-dihydroquinoline. Okay, this is the first reagent. When quinoline is treated with the sodium and ethanol, undergo reduction, there is addition of two hydrogen atom takes place and we get the dihydroquinoline, 1,2-dihydroquinoline. Okay, let us see another reagent. By using tin and HCl, when quinoline is treated with tin and HCl, 4 hydrogen atom adds to the quinoline molecule, 1 to the nitrogen, 2nd to this carbon, 3rd to this carbon, and 4th to this carbon. When that 4 hydrogen atom adds, that 2 pi bonds get disappear, and there is formation of here that 2 pi bonds get disappear, and there is a formation of tetrahydroquinoline. There is a formation of tetrahydroquinoline. Quinoline. This is called 1, 2, 3, 4 tetrahydroquinoline. Let us see one more, third. In presence of nickel catalyst, quinoline when treated with the hydrogen gas in presence of nickel catalyst, here 5 molecules of hydrogen means total 10 hydrogen atom. 5 molecule means total 10 hydrogen atom adds to the quinoline, and there is formation of fully saturated compound. This is fully saturated compound, and this is called decahydroquinoline. And thus quinoline undergo reduction. There is addition of hydrogen takes place, but by using different reducing agent, we get different product. Suppose there is use of sodium and alcohol, ethanol, then we get dihydroquinoline. If we are using tin and HCl, then there is addition of 4 hydrogen atom, we get tetrahydroquinoline. If there is a use of hydrogen gas and nickel catalyst, then there is addition of 5 H2 molecule means 10 hydrogen atom, and we get the decahydroquinoline. This is just about the reduction reaction and also about the chemical reactions of quinoline. Today we have studied one of the important heterocyclic compound, quinoline.